of vectors. So I'm going to break this up as much as I can. So I'm just going to do probably this first page and then break it up almost by page. All right. So bearing and directions are a little different. And if you're taking physics with Mrs. Tidd, then this is something you kind of already seen. So the acute angle between the vector and the north-south line, so north-south line, oops, sorry, I did that backwards, or the north-south line, this will give you like the acute angle. The vector to the right is going to be 60 degrees east of south. So this is the angle that's created right here, but it's 60 degrees to the east side of south. So that's kind of how it's written right here. Okay, so it's kind of weird. It's a little different, but we're going to talk about it. So that's quadrant bearing. All right. True bearing is the angle measured clockwise. Okay, so clockwise from north to the vector. So the true bearing of the vector to the right is 120 degrees. Okay. And if you read it, it says it's written as 3 digits, which is, if it's 15 degrees, it's really 0, 15. Okay. So we're just going to like dive right into this. And right here, pay attention to that note. So let's highlight that. Okay. You can read that. All right. So for each vector, give the quadrant bearing and true bearing. All right. So let's just start with quadrant bearing. Okay. So you're given, and we know this is north, east, south, and west, as I like can't talk. All right. And to find the quadrant bearing, you got to find the angle that comes off of the north or south. So like here, it's saying this is 60 degrees right here, so it's going this way. Okay, so every quadrant is 90 degrees, so there's 5 degrees here. So you always start of like, if it's on the top 2 quadrants, it's coming off the north. And if it's on the bottom, you use south. So it's north, and then it's 5 degrees, and it's on the east side. So basically, if it's in this quadrant, you're using north and east. It's on this quadrant, you're using north and west. This quadrant, you're using, actually, I'll write this, northeast, northwest. And I mean, that makes sense, southwest, southeast. Okay, but that's just the order. You'll write north, depending on what pole it's coming off of, and then if it's going east or the west. Okay, so the question is, what's the true bearing? So let's just read the true bearing again. It's the angle measured clockwise from the north to the vector. So true bearing is like this. Okay, that's really bad. Okay, and if this is north, then it's everything clockwise, right? Clockwise, so clock goes this way from north. So this one's actually really easy. It's 5 degrees, but we have to write it as 0, 0, 5 degrees. Okay, so now on to number 2. So we have this vector, it's 212 degrees, okay, but the question is, what's this? Okay, so to figure that out, you just take 180, or 212, sorry, minus 180, and that will give you the 58 degrees. Okay, so it's on the south side, so it's south, then it's 58 degrees west of south, so that's kind of how you got to think of it. So it's written like that. Okay, so then the true bearing. So the question is, what's the true bearing? So this is 212 degrees here. Okay, but what is it from here to here? Whew. Okay, so you know this is 90, you know this is 90, and you know this is 58. So you get up 90, 90, and 58. 90, 90, so 180 plus 58, you get 238 degrees. So the true bearing for this is 238 degrees. All right.